Welcome back to another explainer. Okay, let's dive right into this. Today, we're putting a magnifying glass on something that is absolutely crucial, but honestly, it gets overlooked way too often. We're talking about the massive, incredibly complex logistical challenges of managing hyperscale AI data centers. We're going to see exactly how total infrastructure software and management in general are evolving to meet these unprecedented demands.
To set the stage here, I want you to consider the sheer human cost of scaling infrastructure the old-fashioned way. Get this, managing 20,000 AI servers manually would take 55 full-time engineers working 24/7. 55! You simply can't just throw bodies at this problem anymore without completely blowing up your operational budget.
Because here is the reality check, right? AI infrastructure is growing 10 times faster than traditional IT. 10 times. That means if you're still relying on legacy manual management tools to run your AI operations, well, it's no longer just some minor inefficiency, it's a direct threat to your organization's survival. The scale is just way too vast now.
Section 1. 4 Data Center Bottlenecks.
So, let's walk through the core challenges data center operators are actually facing out there today. First up, you've got management tool sprawl. When you have separate software for compute, networking, storage, and power, it drastically increases the time it takes to detect and repair issues. Second, scalability bottlenecks. Traditional tools just hit a ceiling. They create isolated silos and drop your availability because they literally cannot handle 20,000 to 40,000 systems. Third is integration challenges. Those siloed systems, they actively block you from building modern DevOps or AIOps workflows. And fourth, no liquid cooling protection. If your liquid cooling management is disconnected from your server management, you are entirely vulnerable to catastrophic thermal failures, and nobody wants that.
Section 2. Enter SuperCloud Composer.
This software represents a massive shift in how infrastructure is managed. Think about it. Instead of relying on 55 engineers trying to manually coordinate across a dozen fragmented tools, compute, storage, networking, power, and cooling are all completely centralized into one single unified dashboard. It essentially turns pure chaos into immediate actionable control.
The contrast here is pretty stark. On one side, you have siloed legacy systems that depend on all these fragmented external dependencies that just break down at scale. But on the other side, Supermicro's SuperCloud Composer, or SCC, is built on a highly available Kubernetes native architecture. It's completely self-contained, containerized, and enterprise-ready from day one. You literally just deploy it and it works.
When we look at competitive differentiators, the most crucial point is right at the top: scalability. SCC can manage upwards of 20,000 monitored hosts without buckling. Add to that its full liquid cooling lifecycle management, a really simple single software kit deployment for both virtual and bare metal setups, and turnkey policy enforcement that automates safety. Honestly, nobody else in the industry is integrating all of these functions into one centralized package at this massive scale.
Now, AI hardware moves incredibly fast, right? So you might be wondering, if this software acts as the brain of your data center, which next-gen platforms are actually supported by SCC? Like, can it handle the absolute newest chips hitting the market?
Well, the answer is a resounding yes across the board. Right out of the box, SCC supports NVIDIA's Grace Hopper, Blackwell, and GB200, along with AMD's MI300X, plus Ampere and Intel Gaudi. It doesn't matter which compute architecture you're relying on to scale up, SCC is built to manage it completely seamlessly.
Section 3. Mastering Liquid Cooling.
Traditional air cooling? Yeah, that just doesn't cut it anymore for hyperscale AI. The heat these systems generate is astronomical. So what type of cooling management does SCC uniquely support to handle this modern reality?
SCC provides a true turnkey solution for the complete liquid cooling lifecycle. What we mean by that is end-to-end management. It starts right from the coolant distribution unit, the CDU, goes straight down to the direct-to-chip cooling, and extends all the way out to the facility's cooling tower. Historically, in legacy setups, these elements were totally disconnected, but now they're completely synchronized.
And let me tell you, that synchronization is a literal lifesaver. Because when you're pumping liquid through a massive data center filled with multi-million-dollar AI racks, the physical risks are incredibly high stakes. So, what kind of events can SCC automate shutdown policies for?
It's built to automatically trigger power-off actions if there are catastrophic coolant leaks or crazy thermal highs. By using automated leak shutdown policies and really precise PDU outlet control, SCC protects the hardware instantly. By reacting to thermal issues the second they happen, it prevents accelerated GPU decay rates. And that directly protects your hardware investment and, ultimately, your bottom line profitability.
Section 4. Built for the future. When you're dealing with critical infrastructure, flexibility and security are everything. You have to be able to install this software on your own terms. So, which deployment modes does SCC actually support?
Whether you're running a standard online setup or you need a highly secure offline environment, SCC gives you complete control. It fully supports standard online deployments as well as air-gapped offline deployments across various Linux varieties. Plus, through RESTful APIs and Redfish integration, it plugs right into whatever open ecosystem you're already running.
Ultimately, SSC acts as way more than just a management tool. It's really a gateway to an open, distributed infrastructure. It simplifies everything from day 0 setup and discovery right on through to day 2 lifecycle operations and maintenance. It literally turns the chaos of 20,000 servers into automated, manageable control.
Which leaves us with one final, pretty provocative question for you to ponder. Will your data center infrastructure scale to survive the next generation of AI? Because if you're still relying on fragmented, manual legacy tools, well, it is definitely time to rethink your strategy and prepare for the hyperscale future. Thanks for joining me on this explainer, and keep learning.